So let's look at what happens when we put an absolute value sign in an inequality. We have a few more things we have to worry about when we do this. But before we look at an example, I want you to go ahead and devote a couple of things to memory. Anytime we see less than or equal to, or less than, in dealing with absolute value inequality, we're going to associate this with the word and. And anytime I see a greater than or equal to, I'm going to associate this with the word or. You'll see why in a few minutes when I do some of these examples. But for now, just go ahead and kind of commit these, that whenever you see the less than, we're going to think of and in our head. Whenever we see greater than symbols, we're going to think or in our head. So let's try an inequality that has an absolute value sign. So we'll start with x plus 5 is less than 2. Now, just like with the equations, I'm going to split this up into two cases, but I have to be careful. The first one I'll just split up into the case you might think. This would be x plus 5 is less than 2, so the positive version of the 2. Since this is a less than, I'm going to insert the word and, just like I mentioned a second ago. And then for my second part, I'm going to take the negative 2 like I did in the equations, but I'm also going to flip the sign. So that less than will become a greater than. So we'll actually flip that sign right there. And so this is something we have to make sure we remember to do when we're solving these inequalities with the absolute value sign, or else you'll get the answer wrong. But from here, we're just going to solve these the way we normally would solve an inequality. So we'll subtract a 5 from both sides here, and I'll get x is less than negative 3. And when I subtract a 5 here, I'll get x is greater than negative 7. Now I have to be careful here. The last step, I need to make sure that my statement makes sense. In other words, are there x values that are both greater than negative 7 and less than negative 3? Well, if you're not sure, just throw it on a number line and check. So this is negative 7 is right here. This is negative 3. There are values that are less than negative 3 and greater than negative 7. So in fact, this answer does make sense. Any of these numbers that we pick in the shaded region should work in this inequality. But any numbers that we pick outside of the shaded region should not work in the inequality. So you can try that. You can pick some numbers and put them into the original, and you'll see that anything from in here works, but anything outside of that will not work. So let's try this one. Absolute value of negative 2x plus 4 is less than or equal to 8. Again, I'll split this up into negative 2x plus 4 is less than or equal to 8. We're dealing with a less than or equal to, so that tells me I should use the word and. And then when I split this next one up, I'll have negative 2x plus 4 switch the sign, so this becomes greater than or equal to. And then this will be a negative 8, and this is what we need to solve. So this is probably the hardest part to remember, is just this little section here. From there, you just solve it like you normally solve an inequality. So we'll subtract 4 from both sides. 8 minus 4 is 4. And then, well, I'll get that in a second. We'll subtract 4 here. Negative 2 is greater than or equal to negative 8 minus 4 is going to be negative 12. And now I'm going to go through and divide both sides by negative 2. But remember, in an inequality, anytime I divide by a negative number or multiply by a negative number, I have to switch the sign. So I'll actually have to switch the sign again. So this will turn into x, instead of less than or equal to, this will be greater than or equal to negative 2. And this will be x is less than or equal to, switching the sign here again, is less than or equal to positive 6. And we have an and in between these two. So the last thing to do is just ask ourselves, does this make sense? Are there numbers that are both greater than or equal to negative 2 and less than or equal to 6? And sure, this is fine. Because if I plot it on my number line, all the numbers that are both less than or equal to positive 6 and greater than or equal to negative 2 will make up my solution for this problem. So let's try one with a greater than sign in it. So again, just like with the equation, I want to get rid of this negative 5 before I do anything, so I'll add 5 to both sides. So that will cancel out there. I'll get the absolute value of 3x minus 2 is greater than or equal to positive 3. Now I'm going to split this up the same way, so this will be 3x minus 2 greater than or equal to 3, and then 3x minus 2, flip the sign, is less than or equal to negative 3. But since I was dealing with a greater than symbol at the beginning, I'm going to put the word or right here. You'll see why this makes sense when we get to the end of the problem. So from here, I'll just solve this like normal. Add 2 to both sides here. 3 plus 2 is 5. Add 2 to both sides here. And I'll get negative 3 plus 2 is a negative 1. Now I can divide both sides by 3. And sure, I'll get that x is greater than or equal to 5/3, or x is less than or equal to negative 1/3. Now the reason this is different than an and is, let's think about how this would work. This is saying all the x values will work in this if they're either less than or equal to negative 1/3, so any value here, or if they're greater than or equal to a positive 1/3, so any value in this shaded region. So we actually get this disjunct group of numbers that would work. Anything that you pick on the shaded regions will work in this original inequality, but anything you pick right here in the middle that's not in the shaded region is not going to work. And again, you can try that. If you pick, for example, 0 and put it into this equation, you'll get a false statement. You won't get something that works. So let's try this guy. Absolute value of negative x plus 2 is greater than negative 3. Again, I'll split this up into negative x plus 2 is greater than negative 3. And then since this is a greater than or equal to, I'm going to put or. And then over here, I'll have negative x plus 2 is less than positive 3. So change the sign of that value from the negative 3 to positive 3. So now we'll solve this. Subtract 2 here, so negative 3 minus 2 is negative 5. Subtract 2 here. 3 minus 2 is 1. Now I need to get this x to be a positive, so I'll just divide it by negative 1. Or you can multiply by negative 1. It'll do the same thing. But remember, when I divide by negative 1, I also have to flip the inequality sign. So this turns to a less than from a greater than, positive 5. And this will turn into a greater than negative 2. So again, a flip from that one. Remember, the word we have going on here is or. So let's see if this answer makes sense. What are all of the numbers that are less than 5? Well, that would be, it would look like this on our number line, right? All the numbers less than 5. Well, but all the numbers that are greater than negative 1, oh, let's see, negative 1 is included in less than 5, so we can actually fill that in. But then all the numbers that are greater than negative 1, that includes positive 5, all the way up to infinity. And since there's an or, we're saying that either of these is okay. Any numbers that are either less than 5 or greater than negative 1 are totally fine. But if you look at the number line, that actually includes every single number. So our answer for this is actually all real numbers. In other words, no matter what x value you plug in here, this will be a true statement. Now, we could have seen this from the beginning. If you take the absolute value of anything, it's always going to be a positive number. So that means it will automatically be bigger than negative 3, because any positive number is automatically bigger than negative 3. So no matter what x value you put in here, you're going to find that that number is going to be bigger than negative 3, because when you take its absolute value, it'll be positive. Now, we didn't notice that when we started working the problem, but we can still figure that out at the end. So that's why you need to kind of check your answers at the end to see if they make sense and how they make sense, and then you can use that to find your answers. One quick thing I did want to mention, when you're doing these absolute value problems, don't fall in the trap of distributing this 4 into the absolute value. You want to actually go through and divide by the 4 first and get something like this: x plus 1. Absolute value of x plus 1 is greater than 3/4. So don't try to distribute that out and have this be absolute value of 4x plus 4. We want to get rid of any of those numbers by dividing first, and we'll get something like this. And then from here you can work this out the same way that we've been working the other problems out.